Okay. All right, so the question one, declare a rate to hold those numbers. So all these numbers are definitely double numbers, right? Because they're just sales amount. Sales amount, it cannot be integer, okay? So we'll say double, square bracket, and then just say amounts equals to new, and then double, and then let's say how many numbers here. So actually if we don't declare that, we can actually use the numbers to initialize. So just say equal to, put all the numbers in there. So 2, 3, 4, 5, comma, 2, 2, 2, 1, comma, 998, 997, and 6, 7, 99, comma, and then 8, 7, 6, 6. Right, semicolon. So without this basically this data will be able to help you to initialize to like 5 sub-blocks because you have five numbers in there. Then you're going to calculate. So what it's trying to do here. So you know the city tax. The sales amount is above that. The rate is that, and then otherwise rate is that. So write the code to determine the compute total sales tax. So we need to declare sales tax variable. Sales tax. Okay, so we are going to add, right? So initialize to 0 first, and then we can use a while loop or for loop, does not matter. So for loop, integer. We can use for each in this case. It will be easier, right? So for each, say double in this amounts. Okay, curly brackets, and then we can just move up and do everything. So if this for each double x, okay, this is just like a use x to represent every amount here, each amount, each number in here. Okay, so if x is, so what does it say? If sales amount is less than, let's say, if above 2,000, and the sales amount. If otherwise sales amount is 8.5. So if x is greater than 2,000, okay, curly brackets. Inside you say sales tax equals to sales x plus x times, that would be 0.065. Is 6.5%, I think, or 5.8, sorry, 5.8. So that would be changing that to 5.8. Okay. Else, so in other cases, if x is less than that, then you're going to say sales tax equals to sales tax plus x times 0.08%, I think. Right, and that's it. That's all you need to do. So that will calculate or accumulate all sales tax for each amount. All right, any questions on this one? Total sales tax, yeah. And then next question is actually an interesting one. Is using Visual Studio to create a simple dice game project with one text box to show the rewards and a button to simulate the play of throwing the dice continuously. So let's just do that. There are many ways to do it. I will do a simple way first, and then we'll do a little bit more involved, more like a sophisticated, depending on what information we're looking for, we need. Okay, so let's just use the Visual Studio to create a new project for that. Okay, so let's just say this is homework 7. I'll save to my desktop. And I put it into 315 here. Okay. That's OK. So create a text box and a button. So let's do button first. Okay. Let's just say that button name is to play, BTN play. Okay. And I can also put a text. Say that's play. All right. And then we put a text box, put it like a text box beside it. Text box besides this button to show the reward amount, right? I'm going to just say TXTR reward. Okay, and then also put, we don't need anything else, just name. Okay. So now let's try to say simulate throwing that dice continuously. So let's read that. Okay. So continuously, each time you press a button, you generate random integers between 1 to 6 continuously until you get 2 consecutive numbers identical. Okay, so how do you do this kind of question? So you're going to generate a number again, right? Until you have 2 numbers are equal. So of course, you don't know how many numbers you're going to generate. Okay, so let's generate. Let's do the simple approach. Okay, let's just say, suppose I'm doing brainstorming, and let's say how can I do it? So I need a random number generator first before I can do anything else. Okay, so let's say my generator equals to new random. Okay, and then let's just try and generate 2 numbers. Okay, so let's say integer x, y. Okay. Or we can just say this first or second. First, second, okay? And then let's generate 2 numbers. First number is, integer, equals to my generator dot next. So when you throw in dice, you get a number between 1 to 6, right? So we'll do, say, generate integer between 1 to 6. Okay, and then do it again, second. That would be also my integer. The next, okay, and 1 to 6. Okay, so your job is finished if F and first one and the second one are the same. But of course, that is only when you're very lucky, right? So if you're not lucky, then you have to generate again. Okay, so you're going to generate 3rd number and then 4th number. So when do you stop? You stop when the 2 numbers are same. So I'm trying to just monitor these 2 numbers, okay? So if these 2 numbers are the same, then I stop. So while they are not the same, if first is not equal to second, okay? If it's not equal to second, then I'm going to generate another number. So what do? I'm going to put the second number into the first, and then regenerate the second number. So first will be equal to second, okay? And then second will be equal to a new number, generate. And also between 1 to 6, okay? So you have 2 numbers, and then you generate again. And you compare, you go back to the while loop to check again, see whether they are equal. If they are not, if they are equal, then you are done. The loop will be finished. If they are not equal, then you do it again. So that basically, this is all the 2. This is the code you need. Does it make sense? But then, how do I decide the reward? So it depends on how many times you run this, right? How many times you run the generation. So I'm going to create a loop, create a counter. Okay, count. So start with 2 first. Does it make sense? Because I already generate 2 numbers, right? I already generate 2 numbers, so the count equals 2. And then if I generate again, then I will make count equals to count plus 1, right? So then you have the count, and based on the count, you will be able to decide how much rewards you get, right? So let's say if, I'm just trying to throw something here, okay? If count is equal to 2, that means the first time you get it right, then let's just put a reward here, txtr dot text, just say $100, okay? You can just write any way of the message that you like. So just say $100, okay? Else if count is equal to 3, or maybe greater than, let's just do some kind of reason, greater than, equal to 3, and count is less than or equal to 5. Let's just say from 5, between 3 and 5, you have different rewards. So txtr dot text equals to, let's say $5. Okay. And let's say else, everything else, let's say rewards is 0. So $0. So this is based on the count to decide. Okay, so this is probably the simplest way, simplest approach. Does it make sense? Okay. Does anybody else have a different solution in this class? We have quite a few smart students in this class. So this kind of question is not just writing code, but also you need to have like a solution strategy. That's how to solve this problem. Okay, so that's the side effects. The side thing. This simplistic approach basically just just say you keep on throwing the game, and then you generate numbers, and then you have 2 numbers. So you get the rewards. Basically, does what the question asks. That's question asked. So question asks you to, if you log it, and so basically it does not ask you to say what are the numbers you generated. You don't want to say the result. What are the numbers you generated? So if you do want to say the numbers generated, for example, some students may say, I want to create the list and then put all the numbers are generated into the list. If that is the case, then you'll probably need to change this a little bit. So let's say in that case, you need to create the list first. Okay, I'm going to do that. So this is the essential part. Okay. So if you want to also have a list to hold all the numbers you just generated, so then you're going to do something like that. Okay, so create the list first, and let's say this is let's just say this is the data, okay, equals to new list. And you cannot use array in this case because you don't know how many numbers you're going to generate. So you have to use a list. List is somewhat like a dynamic array, and the numbers. How many sub-blocks inside the list can be determined when the code is executed. Okay, so at this point you don't know how many numbers you're going to generate, so you cannot create an array for this one. Okay, so if you're going to do that, then you're going to just put these 2 numbers into the array first. Okay, so data.add, okay, and then x first. Okay. Okay, and then you can also do data.add second. Okay, and then inside the loop, you can say you already have the first, second, so now you just need to add the new number into it. So data.add second. So then this will give you all the data you have. So if that's the case, actually you do not need a count anymore, because by using data.count, you will be able to say how many numbers you generated. Okay, and you can use a list. For example, at the end, you have the list box to show data source equals to data, then all the data you generated will be also displayed. Okay, so this will be a little bit more sophisticated approach. Now, if you don't do this, you can actually just work on the list. You can just use the list instead of the first, second, all that to get the final result. That can be done too. So let me say whether I have time to do that. I don't have time to do that. But I will check to see whether anybody has done different approach. So I may give you a different kind of answer for this one. Okay. All right. So any questions for this? Any questions on this hands-on question? Nobody? Okay. So if you have no questions, I'm going to stop here. Close it. Save that. Okay. And then let's see what I will do next. Let me open up today's outline first. So for today's outline, have a review questions, looking for the review question. Let me just ask you a couple of questions here. Let's see whether we can answer them quickly. Can you replace if-else statement by switch statement? No, you can't. Okay. To map or mark like 84 into letter grade. So if you have like points, so like 81%, 71%, those kind of points mapped to grade, and switch statement will not work. Okay, if you need to process text file line by line, which loop you use? You use while loop, right? Because you don't know how many lines in there. So you have to use while loop until you reach the end, then you stop. Okay. And then let's see the binary representations. And then I'm going to skip that one. Default case, switch statement, compared for loop, while loop. So let's say, what is this one? What is the result of this following code? Can somebody tell me? Okay. So you start y equals to like something like empty text. And then x equals to 1. And then if x is less, while x is less than equals to 9, you will just keep on adding x. So this kind of question, just like what I just explained. But this time you are doing text. Okay, you're doing text addition, but not number additions. You see that? So let's just look at one step. Okay, the first step, x equals to 1, right? X is less than 9. So you're going to get a y equals 2. You convert x into text, so which is 1 inside double quotes, and then plus 1. So let me just write that in the board again. Using this whiteboard. So first, y is just like this, empty text, okay? And x equals to 1. So check x is less than or equal to 9. Yes. So you do step 1, okay? So step 1, y equals 2. What do we do? According to the formula, y equals to, you convert x into text and then add to y, to the left hand side. So you are going to do something like this: 1 plus empty string. So that will be equal to empty. This empty. This empty. Okay. So that will be just equal to 1 only, right? So step 1, and then x equals to 2. That, and then you check again. So let me move this up. Okay. Check again. So let's check. Okay. Check. Is x less than or equal to 9? Yes, it is. So you go to step 2. So step 2, y equals 2. Now you convert x, the previous x, into text. So you're going to get a 2, okay, and then plus whatever existing y, which is 1 here. So you concatenate 2 texts into 1, so you're going to get 2, 1, like that. And then x equal to 3 next. So you check again next time, check. X is less than or equal to 9. Yes, it is. So you do go step 3. So now your y equals 2. You change x into text, so the 3. And then plus existing y, which is 2, 1. So what do you get? 3, 2, 1. Okay, see the pattern? So after you finish to 9, then you get a 9, 8. So your final result should be something like this: 9, 8, 7, blah, 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 2, 3, 2, 1. All of them inside of double quotes. So they are text. Okay. All right. And then I'm going to skip this review question here. So I'm going to go to formal lecture for this one, for the while loop. I will have more time to practice that. So for now, we are going to have a couple of concepts about so-called code structure and then functions. Okay, so let's talk about the concepts. So what I will do is I'm going to, instead of using whiteboard, I will use PowerPoint. This is, I don't use PowerPoint very often, but sometimes I found PowerPoint may be a little bit more efficient. So I'm going to download that from eCourse. Okay, let's start. Okay, and then enable editing, slideshow, run the current slide. Okay, so first, just let you know that we spent 2 weeks on how to use if-else, switch, for loop, and while loop. For loop, if-else, and switch allows you to run certain code based on certain conditions, so-called contingency. Based on certain contingency, you run the code. Okay, but the for loop and the while loop is essentially a way to provide to increase write code efficiency, writing code. So so basically you don't want to write so many repetitive code. Okay, so many repetitive commands. Instead, for those repetitions, you put inside the loop, while loop. Okay, and then next section, this week and next week we'll be concerned about how we are going to organize our code so that this code can be reused. So instead of copying code, same set of code from one place to another place, why can we just create some kind of like a unit so that the unit can be reused in some other places if I need to. So just imagine anytime you need to copy or paste the code, then this is what you need to looking for. You need to create something called a function or method to do it. Okay. So before we get into that, we need to understand the program structure in C# or any object in Java also. The program structure, how the code is organized into the modules, into the functions or methods, so on and so forth. Okay, so program structure first. So a little bit warming up of some basic concepts here. First, a variable. A variable is just a memory block. So for example, we have a memory block to hold a price, a memory block to hold like a letter A, and a memory block to hold whether is sunny or not, is it a true or false value, yeah, Boolean value. And here we have a variable to hold like a name, okay, like text, right? So that's just simple variables. And then if we have a lot of variables that we need to create, and they are all same kind, for example, I need to create like 100 prices, then instead of creating 100 variables, then you should use array, right? So create an array with 100 subblocks, and each of them will hold one price in there. All right. Now, what if you need to have a variable or memory block? Can you create a memory block to create like 3 subblocks, but they have different kind of data? So for example, I want to create a memory block with 3 subblocks, one for like SKU, like stock keeping unit, one for price, and one for quantity. Here, quantity is definitely like integer, right? Okay, but the price is kind of double, but SKU is like stock keeping unit is more like a text, right? So because you have text, you have like alphabetical letters inside. So can you create a memory block? Create a memory block with subblocks, but they can hold different kind of data? The answer is yes. Okay, to do that, first of all, you have to create something called a struct. So for example, here is definition of struct. So create struct product, okay? Inside here, I have 3 variables, one for SKU, which is string, one for one is for price, which is double, and one for integer, which is quantity. So after you have this struct, then if you use the struct to create a variable, like I say, for example, product cup. The cup like this is going to have like 3 subblocks. The 3 subblocks determined by this text, by this SKU, by this price, and the quantity. Okay, and then you can put data inside the subblocks like this. So cup.sku equals to this, cup.price equal to that, cup.quantity equal to that. So this is struct. Okay, and before 1980s, And that is all we have to do. We have to use. There's no structure. There's no something called object-oriented programming. There's no objects like classes or that. And this was like a predecessor of a class. This struct is a predecessor of a class. Okay, and this cup is predecessor of object. All right, and in all the C++, this was the only thing we can do. Okay, but now C++ has been extended to be more object-oriented. And then C# and Java kind of like inherited from C++ to make it a more streamlined programming language. So we can use something called a class and objects. So what are the class? What are objects? So here, this is object. This is another object. Okay. So in this object, it's still just a memory block. It's still just like a variable. Okay. The variable will have different subblocks for different kind of data. In addition, you also have subblocks for code, for the code to be executed. Okay. So for example, this is like a dog, okay, Mochi, and then has a birth date and has a breed. All right. But the dog can bark, so that's a function, and then dog can get age. That's a function. So basically, you have a code stored inside its memory blocks too. So what is object? Object just like a stock, just like a variable with subblocks, and the subblocks will hold subblocks of memory blocks can have data and also code. So that is objects. Okay. Does it make sense? So what is a class? A class is just something that you can use to create those memories, create those variables. Okay. All right, so this is summarized. So objects, just more complex memory blocks that store not only data of different kinds, but also program code. Class are template to create objects. Okay, and we have done that in one of the class. For example, if I have phone class, I can create a phone object. If I have a pen class, I can create a pen objects, right? So we have done many of those, right? So we have learned built-in classes. For example, we learned text boxes, labels, buttons, list boxes, picture boxes, and menus, and all of them are built-in classes. And also we learned built-in like non-visual classes like a rundown, data time, pen, solid brush, bitmap, graphics. Do you remember all that? So all of them are just classes. Okay. And what about the how you can say whether you can see the objects. Actually, the object can be visible. Sometimes it cannot be visible. It's just memory block. Okay, but one type of class and object that are visible is a form. So when they design a form, that is a class. Okay, when they design a new form, that's a class. And then when the form is running, that is actually object. So object is actually running form. Okay, but of course, most of the time, we use those objects to do things, but those objects are not visible. Okay, so they're not visual. Text box, we're running those text boxes for you to enter data. Those are objects. Labels, the labels you see, those are objects. Okay, they are visual. They are visible. Good. All right. So here is an example of a class. So I'm show you. We are going to do that in the later class, later part of the course. But for now, I'm going to show you what the program structure look like. Okay, so this is just one class. So inside one program, you're going to have many of these classes. You can have class dog, class pig, class cow. Have many classes. One class will look like this. For example, the class which we used to create the object we just did. So the Mochi class, the Mochi object we did. So it has name, has a birth date, and also has a breed. And also have this is called a function, okay? So we are going to learn how to create those kind of things, all right? So those are the data, and those are the code will be stored in the memory blocks. Does it make sense? So we use this class to create an object called a dog. Let me go back to previous one. Like that, not this, previous one. Previous. This one, okay, so this is a memory block. It has a name, has a birth date, and it has a breed, and also have those code, right? So that where they are coming from, well, basically these memory blocks will be created by the class. Okay, the code coming from the class will be stored in those memory blocks here. Okay, good. Let's go back. So this is just give you the code structure inside the class. Okay, And one project, one system will have one or more of these classes. Okay. So inside each class, you're going to have data, and also going to have this called functions. The functions. Okay. We are going to learn how to create those functions in this week or next week. Okay. So this is another class, a person class. A person has a name, has a birth date, has a job, right? And this is a function, and this is another function, and this is another function. So 3 functions. So if you use this class to create a memory block, then you're going to create 6 subblocks, 6 subblocks. 1 for name, 1 for birth date, 1 for job. So those you can put data in there, right? And then you also have a subblock to hold this code, the grade function, and then create a second function, get age. You need to have another subblock, and then still another block. So 6 subblocks will be created for memory that if you use this person class to create objects. All right, so program structure again. Instructions are organized into 3 layers. So project layer, that is everything, like the entire system layer. Class layer. So inside the project, you're going to have classes. So class 1, class 2, class 3, each one, they are all in parallel. Okay? And then function layer. So inside the class, you're going to have functions. Okay? Function 1, function 2, function 3, like that. Okay? And each layer is surrounded by this curly brackets. Get that? Okay. And then let's forget that, the variables declared. Okay, so if you have variables, variables must be declared inside a function or class, and assignment manipulations of variables must be inside the functions. So I think we talked about that a little bit before. So if you declare variables, the variables must be declared inside a class. That would be global variables, or inside the functions, inside those code modules, and those called local variables, right? So variables are declared inside. But then when you're dealing, how do you put data into those variables? How to manipulate those variables? Those code must be go inside functions. Okay? Okay, so this is kind of like a summary of what we, and enumerations, we did not talk about enumerations, but structures we talk about, struct, right? So there's structs, classes that use defined custom types such as enumeration that are defined inside a project class. Okay? So just this part and this last one, the last 2 sentences, it should make sense. Okay. Now, OO program, there are 2 structures. Static view, static structure is this. So each program is going to be consisting of multiple classes, class 1, class 2, class 3. So you may have like 10 classes or 100 classes. Okay. So in the design time, we actually talking about for programmers and also for business analysts, we talk about programs. We need to understand that this industry is talking about classes. Okay, so we have one person maybe is responsible for one class, and then maybe have a group to handle one class, and also those subclasses. We'll be talking about subclasses later. Okay, so anyway, a program just consists of multiple classes. All right, and then when you're running the system, your system actually will use those classes to create objects. So program will be, in that case, will be equal to object 1, object 2, object 3. You have many objects that interact, that collaborate with each other. So network objects that call each other to perform functions. So a program in dynamic view is just a bunch of objects. Okay, so relationship between class and objects, this class, it will be used to create objects. Class create those objects. Okay. All right, so we are done with program structure. If I'm going to stop here, let me show you. Let's just open up the same code, the code we did last week, and then I'm going to show you the structure again. Just give you a visual sense of what the structure, what we mean by structures. Let's say we did like a 5th example, right? So let's use that, open it. Okay, so let me close everything first. Okay, so now let's say this is a class. The form1.cs is a class. Okay, so inside here you have 2 classes. Program.cs, that's one class, and the form1.cs. So basically your system, your program consists of 2 classes. okay? So if you want to create more classes, you go to project and say add a class. So for example, I can add another class called dog. Dog here, okay? Then, so now you have 3 classes, and I can still create another class. Let's say person class. So person.cs, okay? And then here. So now if you look at this Solution Explorer, you have 4 classes: dog class, form1.cs, program.cs, person.cs, so 4 classes. So your system consists of those 4 classes. Does it make sense? So that's the first layer, highest layer. A project is made of 1 or more classes. You must have at least 1 class, right? So this is the form class. So now let's look at inside the class. So if I just right mouse click on this form 1 and say view code, then you will be able to see the code in the class level, the next layer structures. So what's the next layer? So we have a class called a form 1, which is called a partial class, because in this class is a little bit special. It has actually visual components of class, which Microsoft does not want you to touch, to manipulate, to change. Okay, so this is only part of class. But if you get rid of this partial, then this is public class, the name of class. Okay, and then this class is called a form 1. So inside here, we do not have any global variables, but we have 1 function. We have second function, and here. So this second function. Okay. You see that? So let me show you. If I press this minus sign here, it will actually suppress the functions here. Suppress. Okay. Okay. So now you see how many functions are inside here. You see that? Quite a few, right? There's 1 function here. Okay. So if you look at this structure, basically the class contains 1 or more functions. So here we have many functions, okay? And all these functions are dealing with what does they do? They just basically respond to button clicks. All of them are button clicks, okay? Different buttons, right? So of course you can write more functions. So for example, if I'm going to write another function, just say private, okay? Private, that does not really matter here. Just basically it's just showing that the function is only visible, it's only be accessible inside here. Okay, so if I just try a function to do additions, so 2 numbers, right? So I need to do a function called add. The result of the add is going to be, say, double, okay? And then say sum, and then I have to provide 2 inputs for that, so double A, and then double B, and then this will be the function head. And now if I do function tail, function body, the function body just simply return this A plus B, return A plus B. So this is another function that we just created, which will not respond to those button clicks, but they are just, this function will be reusable in the future. Okay, so this gives you like a sense of the structure inside a class. Okay, inside the class, you have 1 or more of those functions. Okay, so now let me talk about the functions. So we spend a few more concepts about the functions, okay? So this is just first example of function, just do additions of 2 numbers. Okay, so those are 2 inputs. They are called parameters, okay? And then the code will just do additions, right? And then return the result, and the result is going to be double here. Okay, this is the result data type, all right? Okay, so let's go back to the PowerPoint. Run current slide. So to understand the functions, we need to understand the business process. So these terms are exchangeable. So sometimes we call something called functions or process or methods, or sometimes called procedures or modules. So there are many names for this kind of thing, okay? So I will just stick with functions or processes or maybe methods, okay? So if we want, we can actually kind of refine a little bit, but there's no need for this class, okay? For this class, we just understand that those program modules, okay? Like what I just did, like doing some summation, that is a function or method or process, okay? So what is a business process? A business process is just a collection of one or more information activities by which data get transformed, stored, retrieved, modified, or distributed. Okay? And then we understand these activities. So in database class, we talk about create, retrieve, update, delete, right? This is called basic data activities, CRUD activities. Okay? Those are fundamental parts. So you can use many of those activities to come up with a business process. So business process, you remember, it's just like a data transformer. We'll transform data from inputs to outputs. Okay? So if we can think of a process like a black box like this. So for example, if I give you two numbers, A and B, and then this black box is trying to find a max out of this, right? So the output is going to be max out of A and B. Okay? So this is more like a business process representation. Okay? And this is actually formally this is called a data flow diagram. So we have data flows in and data flows out, right? So data flow diagram show the business process view. Okay, database. So this is what you are going to learn later, but not now. So basically, at this point, we just need to make sure that we know how to write a business function head based on what is input and what output, and what's inputs, what are the inputs, and what are the outputs. So this is what we need to know. Okay, and we do not need to know very details about how to draw data flow diagrams, more sophisticated data flow diagrams. All right. Okay, and so here is another process. So suppose I need to write a function to validate your user login. So every time you log into eCourse or log into Brightspace, you need to provide a username and password, right? And then there's a function to tell whether that your login is valid, yes or no. Okay, so in that case, you have two inputs: username, password. Output will be yes or no, valid or not valid. Does it make sense? So this is another example of data flow diagrams here. All right, so now let's say how does that translate into the functions that we are going to write? So this is an example. Suppose I have two integers, A and B, given two integers. The function is just trying to add those two numbers, A plus B. Okay, so output is going to be A plus B. Input will be A or B, those some of the integers, or maybe some kind of numbers. Okay, so from this, we can write function head like this. So first, you decide what kind of output is it. So the output in this case, because you add two integers, so the output is going to be integer, right? So you put integer here. Okay, and then what's the name of the process? You copy the name here as a function name. Okay, and then finally for each input, you're going to create them as parameters. So we have two inputs, A. So integer A and integer B and integer B. Yeah. So that's how you create a function head based on this so-called business data flow diagrams, business process flow diagram. All right. So how do we write a function? So this is what you need to make sure. So first you need to know what are given. Okay. The function has to work based on the given data, right? So here the function based on integer A and integer B to start work. So those are two givens, and then you need to decide what will be output. Okay, and output you don't need a name, but you just need to say what kind of data for the output. So integer, right? You put integer here. Okay, so that's how you write a code. Map this kind of like a business process view to function code. Okay, so let's say we have another example. We have suppose I have two numbers, decimal number A, decimal number B, and I'm trying to find the max of these two numbers. So you're going to put max of A and B is going to be decimal also, right? So write decimal here, and then you copy find the max into here. And then you have two inputs as two parameters. So input that will be decimal A and decimal B. Decimal A, decimal B. Can you say that this is just like you declare variables, right? Okay. So say decimal A. So that means you declare variable A, and decimal B. So you have another variable. So when you're writing code, you do not need to declare this A and B again as a variables because they are given to you. Okay, they are assumed to be given to you. So when somebody call this function, then they will provide you A and B's. Okay, so you do not need to declare variables A and B again inside the code. So the code for this one is going to be simple. So say if A is bigger than B, then you return A, right? And if B else, if B is not, is A is smaller than B, then you return B. Okay, so you put curly brackets here, opening here, and beginning and closing here. Then this will be the complete function. Okay. All right, I think, yeah, that's the complete function like this. Okay, so basically that's what what is the function finished. Okay. What if a function does not have inputs and outputs? Is that possible? Yes, it is possible. The possible in certain circumstances. So for example, if a function needs to get a time, current system time, the system does not need you to tell the system time. The system can get the function can get a time from the computer, right? So in that case, you may not need input. Okay. So let me say here. Suppose I want to try to create a function to grade, say good morning, good afternoon. I think we wrote that kind of code before. So in this time, the function can get current time from the system, which is system.time, that system.time.now, right? So this function grade does not need input. However, you can generate output. Output will be say good morning, good afternoon, or good evening, right? So you can create a function. So what is the function here? So return type is going to be string. But then parentheses, inside parentheses, there's no parameters. You leave it empty, right? And then you write a code. So data type, get current time, and get current hours. And if hours between 6 to 8, 12, yeah, then you say greeting equals to good morning. Else, if it's between like afternoon, like 12 and 18, then you say good afternoon, right? And after all that, you say return my greetings. So then the function will return either good morning, good afternoon, good evening, based on the current time. Okay, the current time is known by the program. Program can get the time from the system. So there's no need for input. Okay. So what if I do not need to, return anything? I just basically say if I, use good morning, like the function say good morning. It's just like speak out. So like use a message box to speak out. So in that case, there's no output also. So if there's no output, you put a void instead of some kind of data here. Okay, so for example, in this case, the greeting is also getting data from the system, from the clock, so get a current time, and then the function will do something like this: message box show, say good morning, good afternoon. So in this case, you're not returning anything. This function is not returning anything instead of just saying out, okay, speaking out. So if that's the case, there's nothing to be returned. You make that data type output. There's no output, so just say void. No output, the void, okay? And then everything else will be the same, okay? So finally say message box show, and then your computer will speak out good afternoon, good morning, whatever, okay? But this function is not returning good morning, good afternoon to anybody. Is that clear? Okay. I'm going to do, let's say whether I have time. I have like a little bit over 5 minutes. So we can create one function that is okay, call functions. We're going to do that a little bit later. So I'm going to stop this PowerPoint, and then let's go back to the code. Let's say whether we can create a function based on this. Okay, so we say go to form 1 here. Let's run there. Yeah, okay, so what we did here? We did a factorize, we did a binary, we did ASCII code, the weekday, phone. So we should be able to create a function based on existing code. Let me just do this. Okay, let's go to form 1. Okay, so we already created a function like this, right? Created like a, say, double find the sum. Okay, let's just trying to redo the code. Okay, let me tell you where to write the code, write the functions. Okay, first of all, you need to find the project. So this is just like a top layer. Okay, this is a namespace, and inside that you're going to have a class. So sometimes you may have one or more of these classes, but in this case you have only one class. Okay, so just find out the class first, find the class inside the project. And then inside the class, now you say something like variables or functions. So if you press all this like minus and make that suppress, then you're going to say a lot of things in parallel, like function, 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 right? So you are good. So I'm going to suppress this one also. So you're going to create functions in parallel to all this, okay? So it does not matter where you put it. You can put it in the beginning or put it in the end. So I'm going to put in the end. So go to the end, the very last one. So let's create another function. So the function is going to do max out of two numbers, okay? So private, okay? Max, suppose I'm going to find the maximum out of two decimal numbers. So let's say double, okay, max, okay. And then say double A, double X, and double Y. So those are two inputs, okay? And now this function head and the curly brackets. Okay, so this function, this the program, the process data flow diagram showing that you have two inputs, right? And then based on here, two inputs, you're trying to find what is the maximum out of these two. So I'm going to say if X is greater than Y, okay, curly brackets, and then say return X. So X will be maximum, right? Else, okay, then say return Y. So else means X is less than or equal to Y, right? X is less than or equal to Y. So in that case, both of them are same. If they are the same, then it does not matter which one. So, but if X is less than Y, then Y should be maximum. So this is a function, okay? And then we can suppress that and create still more functions. So this time, let's do a function which is also very simple. Let's say I want to do divisions, okay? So public, private, okay, double, okay, let's say divide, okay? So I'm going to divide two numbers. So I can say double A, double B, okay? Divide two numbers. So what do we divide? We divide A by B, okay? So if B, so in this case, we have to be careful because B may be 0. So A divided by B, if B is 0, then you cannot divide, right? So we'll say if B is not equal to 0, is not equal to 0, then we return A divided by B, okay? So what if they are 0? What if B is 0? Else, well, if you just stop here, if you do A divided by B, then B with the code will crash. So what I'm going to do is, in that case, I will throw new exception. So inside exception, we can tell what kind of exception. Divide by 0, error, something like that, okay? Okay, so we have a third function created. So this time we do divide A divided by B. Okay. Let's do one more function, which is also pretty simple. So this time I want to use a function to decide whether an integer is an even number or not even number. It's odd or even. So think of this question. You try to decide whether an integer is even or not. Right? So a function is trying to look at given what is given the integer, and then your decision is whether it's even or not, right? So we are going to. So if you're going to write a program, write a diagram, the diagram should look like this. So I'm going to put it quickly here. Okay. So say you're going to use a function to decide whether it's even or not. Okay, it's even. Okay, that's a name. And what is input? Input is some kind of integer. Maybe A, okay? And what is output? Output is yes or no, right? Even or not, right? Okay, so what is output? Output is going to be Boolean, right? Okay, what is input? Input is integer, okay? So we are going to write a code or coordinate like that. Okay, so we say private is even, private bool, okay, boolean, which is return type, okay, return type, and then is even, okay, and then input is going to be integer a or integer x, whatever, okay. So how do we decide? If a can be divided by 2, then that's even. So if a wholly divided by 2, that means the remainder is 0, then we'll say return true, right? Yes, that's even. Else, return false. Okay, so in just like those 5 minutes, we finished 1, 2, 3, 4, 5 functions. Okay, so I'm going to continue this next class, but just let you know that to create a function, the first important part is you need to create a function head. Okay. All right. Don't forget to upload your class note to show as a proof of attendance, and I will see everyone on Wednesday.